This is lesson 24, ionic bonding. So remember Lewis symbols. Okay, Lewis symbols are really important. They show the number of valence electrons, just written as dots around the symbol for an element. And remember that atoms like to gain, lose, or share electrons to have 8 valence electrons total, and that is called the octet rule. So which is the only noble gas that does not have an octet? Remember, that's helium, and helium only has 2 because 2 electrons will fill the first energy level. So ionic bonding is an attraction between oppositely charged ions. It's an electrostatic attraction. And ionic bonding occurs with metals and nonmetals, so a metal bonded to a nonmetal. And remember that in ionic bonding, metals lose electrons to form ions, positive ions called cations, and nonmetals gain electrons to form negative ions called anions. So to show the movement of electrons, we use arrows. Okay, and so for example, sodium gives up an electron to chlorine to form a positive ion, and chlorine becomes negative. And brackets are used to show the electron dots, or the Lewis dot symbols for ions. Remember, ionic substances are brittle, they have high melting and boiling points, they are crystalline, and they can be cleaved, which means you can break them along smooth surfaces. Forming ionic bonds is very exothermic, so they release a lot of energy because they form crystal lattices. The lattice energy of an ionic compound is the energy required to completely separate 1 mole of a solid ionic compound into its ions as gases. So if you were to separate sodium chloride into sodium ions and chlorine ions that were gaseous, it would require 787 kilojoules per mole. So separating a lattice is very endothermic. It takes a lot of energy to separate a lattice. And the magnitude of the lattice energy depends on 3 things. It depends on the charges of the ions. The greater the charge, the harder it is to separate. The size of the ions, as they get smaller and smaller and closer together, it takes more energy to separate. And also the arrangement of ions. And to describe this, we use a law called Coulomb's law, and that energy is equal to a constant times charge 1 times charge 2 divided by the distance. So as the distance increases, the energy required to separate them actually decreases, and as the distance decreases between the charges, the energy would increase. So lattice energy increases as the charges increase and as the radii decrease. So here's some lattice energies for some ionic compounds, and you can see that things that are made of very small ions have a very high lattice energy. It's difficult to pull them apart. And you can also see that as the charge increases, for example, magnesium is +2, it's also very difficult to pull them apart. So trends in lattice enthalpy energy. They are opposite the radii. Okay, so as radius gets bigger down a group, lattice energy decreases down a group. It's easier to pull them apart because they're bigger. Lattice energy will increase across a period because the radii, remember, get smaller and smaller and smaller, so it's harder to pull them apart. Remember, the octet rule does not always solve every problem. Transition metals do not form octets. Transition metals lose their valence electrons first, which are the 4s, 5s, etc., and then as many electrons in the d subshell as they need to.